Our final topic in this section is solving systems of linear equations algebraically. Now, there's two ways to do this, which you've done many times before in your math lives, I'm sure, and I'm just going to do a review of each of the ways. So one way is called substitution. And I'll use it to solve this system. Find the point where the linear functions h of t equal 3t minus 4 and j of t equal 5 minus t intersect. It might be that you're more comfortable doing this using y notation. So the first thing I'm going to do is change this into y notation. So y is equal to 3t minus 4, and this one could be written as y is equal to 5 minus t. Now, remember, with substitution, what you do is you literally substitute one expression into the other equation with the goal of creating an equation that only has one variable. So since y is equal to 5 minus t, I can replace y in this first equation with 5 minus t. That would give me an equation that looked like this. 5 minus t is equal to 3t minus 4. So now we have an equation with only one variable. And an equation with only one variable is pretty easy to solve. So we'll add t to both sides. And we'll add 4 to each side. Let's try that again. So this gives us 9 is equal to 4t. And we'll divide both sides by 4. And we get t is equal to 9/4. And now, of course, we need to find our other variable. So what we can do then is just substitute this value into either equation. So 5 minus t, for example, I'll put it into this equation here. 5 minus t would give us 5 minus 9/4. In other words, 20/4 minus 9/4, just getting a common denominator, and that gives us a result of 11/4. So our t variable is 9/4, and our function output then is 11/4. So these lines would intersect at 9/4, 11/4. And that's substitution. The other technique, which you probably remember, is called elimination. Find the point where 2x minus 3y equals 12 and 5y plus x equal 30 intersect. So 2x minus 3y is equal to 12. When I write this second equation, I'm going to make sure that similar variables are written underneath each other. So I'm going to rewrite this as x plus 5y is equal to 30. And now this probably jogs your memory as to how this works. What you want to do is you want to line up the coefficients so that one equation has a positive coefficient and the other equation has the negative coefficient with the same value. So what I'm going to do is I'm going to take this second equation and I'm going to multiply by -2. So let's see what that gives us. So our first equation was 2x minus 3y is equal to 12. If we multiply the second equation by -2, we have -2x minus 10y is equal to -60. And now if we solve, we have -13y is equal to -48. And if we divide both sides by -13, we get something that's, again, a fraction, I think. Let's see. 48 divided by 13. Yep, that does not go in evenly. So y is equal to 48 over 13. Okay, and so then you might remember, well, how do we find x? The way we find x is simply by taking this value for y and plugging it into either equation. It doesn't matter which one. I'm just going to put it into the second one here. That gives us x plus 5 times 48 over 13 is equal to 30. And from there on out, it's just tedious arithmetic. We'll go ahead and finish it. We'll multiply these together, so 48 times 5, that would give us 240. All right, so what we have so far is x plus 240 over 13 is equal to, now I know I'm going to need a common denominator, so I'm going to rewrite 30 in 13ths. So if we figure out what that is, 30 times 13, that would be 390 13ths. And we'll just subtract 240 13ths from each side. And we get an x value of 390 minus 240, 150 13ths. All right, so here we have an x value, here we have a y value. So what that would mean graphically is if we were to graph these lines would intersect at the point 150 13ths and 48 13ths. Okay, so hopefully that process is one that you kind of remember doing ever since you started taking algebra. How can you tell if two lines will not intersect? Well, one way to tell that two lines won't intersect is simply by looking at their slopes. The only lines that don't intersect are lines that are parallel. If lines are not parallel, they are going to intersect. So this line has a slope of 2/3. We can clearly see the slope of the first one. Now, the second one, we don't know its slope, but we could easily find it by solving for y. So we're going to take this equation, and we're just going to take a moment to solve it for y. So we'll subtract 3x from both sides, and we'll divide both sides by 2. And we can see that this line is going to have a slope of negative 3/2. Well, let's look at the slopes. The first one was 2/3. The second one is its opposite reciprocal. These lines are perpendicular. And so since these lines are not parallel, they will intersect. And so to find the point of intersection, if we wanted to find it, we could either use substitution or elimination. So now you try it. Find the point where these lines intersect, or explain why this point doesn't exist. Finally, here's an example of an application of the intersection of lines. An application of the line intersection is the break-even point. A company sells sports helmets. The company has a one-time fixed cost of $250,000. Each helmet costs $120 to produce and sells for $140. Find the cost function, C of x, to produce x helmets. Find the revenue function, R of x, from the sales of x helmets, and find the break-even point. So let's draw a picture of this situation. Okay, so first of all, cost and revenue depend on how many helmets are produced and sold. And so cost starts off, and costs build over time. So your cost is here. Revenue, you start by making no money, and then you begin making more and more money. Okay, so we'll let the purple line be revenue. And this point right here where the lines cross, where they intersect, this is called the break-even point. Up until that point, notice your costs are more than your revenue. This means the company is losing money. After that point, notice that your revenue is greater than your cost. That means the company is making money. And so what we're going to try to find is this intersection point, because that's the point where before that point, the company is losing money, and after that point, the company is making money. So in order to do that, we have to be able to write each of these functions. So the cost function, we've seen this before in a previous section. The cost function is your fixed costs plus however much it costs per item. So it has 1 times fixed costs of $250,000, and it costs $120 to produce a helmet. So your costs are $120 per helmet plus the $250,000 in fixed costs. Your revenue is how much you take in. So your revenue is going to be $140 for every helmet. And what we would like to do is find the break-even point. Another way of asking that is find out where these lines intersect. Now we can see that these lines have different slopes. And so since these lines have different slopes, we know that they're going to intersect. So I think the fastest way to solve this would just be with substitution. Think of this as y equals. So I could just substitute this y, 140x, into the other equation, and then that gives us a system that we can solve. So 140x is equal to 120x plus 250,000. If we subtract 120x from both sides, we have that 20x is equal to 250,000. And the finishing touch, we'll divide both sides by 20, and we're going to come up with an x value of 12,500. So what does that mean? That means that up until the selling of 12,500 helmets, the company is going to lose money. But as soon as their sales cross 12,500 and they start selling more than 12,500 helmets, then the company is going to make money. So their break-even point is right here, where x is $12,500. And then you could find the y-coordinate to see what the y value would be at that point, simply by taking 12,500 and putting it into either equation. Just to finish it off, we'll go ahead and write that into your notes. So I'm going to put it in right here. So 140 times 12,500 gives us this value here. So at the point where their sales are $1,750,000, after that point, they will be making a profit.